This evening, we are delighted to continue our virtual programming, a, uh, a format that we plan to continue for the foreseeable future. We found that so many people around the country have enjoyed these presentations, and we're reaching a much wider audience to accomplish our mission and goals, not only to schedule lectures and webinars on Japanese art and culture, but also by publishing our peer-reviewed scholarly annual journal, Impressions. Tonight, the program committee of JASA has planned a special presentation on the blue pigments used in both woodblock prints and paintings during the Edo period. I am delighted to introduce our special guest speaker, Dr. Marco Leona, Chair of the Department of Scientific Research at the Metropolitan Museum of Art. He will share the studies of his department and his collaborations with historians, art historians, and curators worldwide. With the Met's outstanding collection of Japanese screens, paintings, and woodblock prints, he has had a wonderful chance to delve deeply into the science and materials of pigments for these works. And tonight he will discuss the artistic revolution evidenced by the introduction of Prussian blue pigment into Japanese printmaking, but also, and as importantly, to introduce unique and remarkable works by various artists of the Rimpa school, especially Kōrin, and a remarkable work by Jakuchu that he has also studied in person. The importation of that pigment was one of the many factors that marked the end of Japan's seclusion enforced during the Edo period. So tonight, may I introduce Dr. Marco Leona. Thank you.
Thank you, Emmy. I want to give you my really heartfelt thanks for inviting me to give this lecture. Also, my thanks to the JASA organizing committee. It's a wonderful organization. I really enjoy reading Impressions. I published in Impressions, and I love all your programming. It is a wonderful opportunity to be able to speak to the JASA member, to the audience, about what has been a very personal adventure and travel along the road of color in Japan. I've worked on art from all over the world and from every time period, but Japanese art is what really moves my heart and what gets me going in these scientific investigations. And I really want to look at how material choices are fundamental for the mission of the artist to signify a meaning. We're looking at a few works made from the Edo period, made during the Edo period, and next week we'll be talking about the Meiji Revolution, a revolution also in science, in commerce, in industry, and in color. But the seeds for what happened there really were planted before. And what I see when I look at the Edo period and at Japanese artists is that these continuous research into new ways of expressing artistic aesthetic concept is really a key factor. Working in a museum like the Met, where we have art from every continent, we are used to apply the most advanced scientific techniques to the study of these works. Traditionally, typically in the study of European paintings, you will see all kind of advanced imaging techniques, infrared, X-rays, lasers, microanalytical techniques, all used to understand the very complex, heterogeneous nature of these paintings. Traditionally, East Asian paintings are thought of as simple because the technique is nominally simple. It is essentially distemper, what would be called distemper in Europe. So kind of a gouache medium, pigments thinly bound in a protein binder. There's very little layering, there's very little transparency, glazes, Everything is alla prima as you see it. Um, and by these, I'm painting, so to speak, in very broad strokes. But what we discover as we started applying scientific methods, it's really the depth to which the visual effects achieved by Kōrin, Jakuchu, Hokusai, and you name them, go. And hopefully I'll give you a sense of that. I am in great debt to many people who put me on this path. My title or subtitle, The Colors of Space and Time, comes from a wonderful publication by Henry Smith, Hokusai and the Blue Revolution in Edo Prints, a paper that is available for open access download on the web, and opens with this beautiful detail from a print at the Brooklyn Museum, which Amy knows really well. Henry was the first to write about this epochal shift in aesthetics, really, that happened when Japanese printers got access to Prussian blue. And we'll talk about that more towards the end of this talk. But in turn, I was introduced to this article by a great mentor and a dear late friend, John Winter. You see him here in the laboratory at the Freer, where we were carrying out fiber optic reflectance spectroscopy. That's actually the instrument that I used for 2 years, analyzing 200 paintings. And that's actually where I sat for 2 years, that room. So it's always a pleasure for me to see this image of John, who, among all other things, wrote what is still the greatest book on the materials and techniques of East Asian paintings. Well, let's talk about blue very quickly, and about the blues that Japanese painters would have used. Here you see them. This is just simple pigment mixtures painted out on watercolor paper, European watercolor paper. Azurite, a copper carbonate, a mineral that was ground to different degrees of fineness to achieve the appropriate shade. Smalt, a glass that contains cobalt, a deep blue with a hint of purple. Indigo, probably the most ancient among the organic color and natural dyes, extracted from a variety of plants, most typically used to dye denim in the West, but always used also as a pigment. And finally, to the right in my little chart, Prussian blue, the invention of an alchemist in Berlin in 1704, mixing blood and iron. He came up with this interesting pigment. Somebody jokingly, actually it was John Winter, said like blood and iron, that would be Prussian. But these pigments were put to fantastic uses and incredible visual effect by Japanese artists, and I think none better than the Rinpa artists. Here you see Morning Glories by Suzuki Kitsu. That's me taking a sample at the microscope. All of our work, as much as possible, is done with non-invasive techniques. We do not want to intervene on the object, but sometimes we have to take microscopic samples to continue our analysis, and that is how it's done. Let's go back for a moment to what I said about the technique of Japanese paintings. The fact that the pigment mixtures are thinly bound granular pigments with just a little bit of hide glue, nikawa, as the binder. This type of medium allows the artist to achieve the soft texture, the almost velvety feel of the flowers in this example. You see it even more in Kōrin's irises or yatsuhashi, here shown while we analyze them by X-ray fluorescence technique, a method that sees what elements are present in a painting. So copper will indicate, in this case, the blue pigment azurite. If we take a high magnification picture, we see more clearly what I'm saying. The extremely large crystals that you see are the highest grade, the most expensive grade of azurite. The mineral, when its crystals are so big, has the deepest color. The intensity of the hue of the blue pigment is extreme. And Kōrin, as all Japanese artists, uses it to its advantage to go to the deeper tones. But the fact that, unlike, let's say, a European painting where you wouldn't see the individual grains embedded as they would be in oil, the fact that you see the paintings, the grains of pigment so distinctly is what gives the soft, fuzzy, evocative aspect of the petals. In this case, you almost imagine touching them and they would feel like a real flower. I also want to point out, in the case of the work in question, the gold leaf that you can see on the left side of the image, and how thin the gold leaf is, because it still shows the texture of the long fiber paper underneath. So let's start our digression by looking at art, a broader view, not the microscopic view. In this case, the irises at Yatsuashi, a pair of 6 fold screen at the Met. We conducted an extensive study of these masterpiece because we wanted to investigate issues such as the color loss that you can see in some areas, but also the preparation, how Kōrin built his picture and how it compare to the related pair at the Nezu Museum. Here, our screens and the Nezu ones are shown together, installed at the Nezu in occasion of the exhibition that brought them together for the first time, I think, in a century in Japan. And we were taking our moves from an article that was published on the Nezu screens, where the colleagues in Japan had highlighted the construction technique, the way the paint was, the gold was applied, and then the paint. And one thing that was striking was the fact that they mentioned that the screens were gilt in their entirety. The screen were gilt, leaving in reserve the area where the flowers would be painted, which is the more traditional way of painting these type of screens. One of the key reasons to do that, so to leave the area where you paint without the gold leaf so that you can paint on the bare paper, is that paper presents a better surface for adhesion of the pigment. Now, as we looked at our screens under the microscope, we noticed that the gold leaf went under the blue. It did look like, in this case, that traditional preparation had not been kept, that the screens had been gilt in their entirety, and then the painter had applied the gold leaf, the azurite paint directly on the gold. Looking at other details, something struck us also, that the fact that you see white pigment visible in areas where the blue is. And we started thinking that possibly Kōrin had applied an intermediate layer, a layer of fine white gofun between the gold and the blue. And we set out to demonstrate it with a full-scale analysis, which would include characterizing all of the pigments and hopefully understanding what happened overall. You can see things that are typical of Japanese art. As I mentioned before, the degree, the particle size, the degree of fineness of the pigment. And here you see 2 areas bordering one another. We'll take a look later at the painting in full to understand where they are. An area of very large crystals and an area of very small crystals. This is how Japanese painters, and you probably all know, select their pigment. They create different shades let's say, of blue, not by mixing white to blue to make it lighter, but by selecting a finer grain pigment. The larger crystals are deep blue, the finer crystals are uh, lighter blue. And this is actually, there is a physical reason to it. Finer crystals give more light scattering, and light scattering is essentially like adding white to a pigment. Just they do it with light, they don't do it by mixing two materials. You also see here at the center of the image going horizontally, the underdrawing. This is how Kōrin prepared, laid out the image, and it's barely visible here at this area where a deep blue petal meets a lighter blue petal. The same thing is done with the green. In this case, the crystals are even larger. You see an area of a deep green with very large crystals, and here, fine crystals which have a lighter green color. The pigment is malachite, another copper mineral. To prove whether really the gold continued under all of the flowers, we work with a colleague from Japan, scientist Kaori Fukunaga at the National Center for Telecommunications in Tokyo, who had developed a technique based on terahertz radiation, a form of microwave radiation that can penetrate painted layers and is reflected by gold. So in this case, we studied a detail of some iris leaves, partially overlapping in some areas, but otherwise painted on the gold. And with this technique, we first look at a line along this direction, essentially sectioning virtually the paint. So looking at the depth of the painting, a little bit like a sonar would try to see the depth of the sea. And what you see here is the really a sharp, bright white line, which is the reflection of the waves at the gold foil, and a weaker line, which is the profile of the painting. It's almost as if we had radiographed in profile the paint. And what you can see here is like high thickness where two leaves overlap, but overall very strong reflection from the gold, which is underlying all of the paint. If paper had been there, we wouldn't see this straight line. And in this area, we actually do, something like a few hundred of these lines, and then we take this result and build a whole image which shows the full reflection of this area. And as you can see, the green being transparent to this type of radiation does not show, but we have a uniform, very clear, very high reflecting background, which shows that the gold goes under all of the picture. So we could prove that Kōrin did something different in this case, that he chose to paint directly on gold, assuming the risk that the paint would not adhere and could be lost, but in a sense, giving himself a little bit more freedom to change things at the last minute, because he didn't have to deal with the reserve technique, having left the paper bare in some places. To add another layer of investigation, we used infrared radiation, just like infrared imaging, an infrared camera, just like it's very often used in European paintings to, again, penetrate the paint layer, the colored areas, and see underneath if there are details such as ink lines, the underdrawing. Infrared imaging gives us a much better resolution. It's the same quality as a photograph, so a better image compared to the terahertz image that you just saw. There we discover something else that is very interesting. So this is a detail. You can see the two blues I was talking about, the dark blue and the lighter blue. These are done using different particle size of azurites. You can see here that overall, even though there's not a dramatic difference, but essentially we're seeing a pretty good reflection from the background, just with the shading here due to the pigment, another indication that gold goes through. But I want you to pay attention to a couple of details. I mentioned two blues. And if we pay attention, really, there is, let's say, one blue here, which is the light blue. And then when we look at the dark blue, you see that there is a gradient. We go from a deep blue to a very dark blue. And the same is here. At the center of the flower, there's something like looks like an arrow. There's some shading. So the blue has become even deeper. And that indicates the volume, the curvature of the petal. It does suggest that this is a three-dimensional structure. It's not flat. That's very important. That's what artists do. It's called chiaroscuro in Europe. It's clearly used here by Kōrin, even though he chooses some type of abstract and idealized version of irises. The gold background, for instance, just like makes these clumps of flower kind of floating in space, but he is giving volume to the flowers. When we take the infrared pictures, suddenly the dark shading disappears. The image is much flatter. We see the brush stroke of Kōrin, the brush strokes that he used for applying the azurite, but the shading disappears. And that was a puzzling discovery. We didn't know that there could be a technique that would work like this. It's clearly not using, it's not making the azurite darker by going to even larger crystals. You can't. He was already at the larger size crystals here. So he did something altogether different here. He applied on top of the azurite a pigment that succeeds in making the blue darker. It keeps the hue, the tone of the blue pure, very blue. So it's not black ink. It's very saturated, but it's transparent to infrared. And that's where we took a little sample. And when we look at the pigment grain, the ones that look like glass are these small crystals of copper carbonate mineral, but we see attached to them dark blue particles, very, very opaque, very fine. And by using another technique called Raman Spectroscopy, where we focused a laser beam exactly on top of these crystals, we were able to detect that that blue was indigo. So this is a technique that nobody had heard of or documented before, where to make the blue darker, it went over and just applied a thin wash of indigo, the very traditional pigment, to darken the azurite and suggest depth. And the effect, if you think about it, it's truly powerful. As I say, the clumps of irises, and this has been noted before by art historians, they have a powerful suggestion of volume and depth. That is due both to if you want to the micro level. Each petal looks like it's curving in space, but also the clumps have this strong pyramidal composition. The use of infrared gave us another revelation there. Look at this image. So azurite is semi-transparent. The blue pigment in infrared becomes semi-transparent. Malachite is still very opaque. It's not penetrated by infrared very well. And so what you can see is here how the leaves, they continue. He carefully planned the composition by painting the leaves and interrupting them where a petal would be, then restarting them, etc. But so if you see here, transparent pigment that is transparent in infrared, pigment that is opaque in infrared, the green is not under the blue. But look here, this petal has been painted over the stalks, over the leaves of the irises. It's been added after this clump was painted. And likewise, this one, there's another one at the top in one area that shows that. This in European paintings is called a pentimento. It's where the artist repents from a compositional mistake and adds something at a later stage. And I think this is also the first time that we hear about this modification made by an artist. Now there's a story, we know that for this type of painting, the artist would be paid by the number of blossoms he painted, as if you were going to the florist to buy a bouquet. I don't think Kōrin was really trying to do this to make a quick buck. And the way to see it is by comparing, by looking at the image. See, this one blossom that was painted over after the composition was already made is this one. It's much larger than others. It's right in front of you. And imagine if this was not here, how flat this clump of irises would look. But with this last one added at the last minute, Kōrin was able to push back the rest of the flowers and really give depth to the scene. This is what in stage practice, this is called a repoussoir. It's a French word. It means to push back. By adding something in the foreground that's larger, you give impression of depth by making what's behind look smaller. And so I think that this is really what Kōrin planned when he moved from the traditional technique used for the Nezu screens, which are earlier, to this execution. He devised a method that would give a uniform gold surface, fully prepared, where he could quickly sketch the general arrangement of the clumps. He started working on them. He had to solve the problem of giving good adhesion for the blue pigment onto the gold, which is difficult. And he added the layer of gofun. Gofun is a fine pigment, creates a very nice layer, and the blue can adhere better to it. Also, it masks the yellow tint of the gold so that the blue would come out stronger. And then he uses, and he probably used that in other paintings as well, he uses washes of indigo to darken the blue where necessary to suggest rounding and depth. And that method allows him to paint with more freedom, where last minute changes to the composition could happen to heighten the depth effect. Incidentally, I believe that the method of using indigo to darken blue without desaturating it, that means I like adding black to blue to make it darker, or adding white to blue to make it lighter. Adding indigo instead of a black allows the painter to darken the color without making it less blue. That's what I mean by keeping it saturated. Blue, to me, seems to have a very special value in Japanese paintings. And I want to show you now a rather quirky painting, a painting that is more mysterious, if you want, and certainly peculiar. This is a very small detail executed with a very strange technique, with a very particular device, these sort of pixelated mosaic tile. And you probably know what the painting is. This is a Mina bird, a small detail from this painting, possibly by traditionally attributed by Ito Jakuchu, birds, animals, and flowering plants, which I studied when it was in the Etsuko and Joe Price collection, now part of the Idemitsu Museum of Art collection. And the bird is here. It's over here. And I was asked to look at it because I was told that as you walk in front of the painting, the bird changes colors. It goes from black to blue. And that sounded like a rather odd statement. It's almost saying like the Mona Lisa follows you with her eyes as you walk in front of her. Not that you could really, it's very crowded. But it was very interesting. When I walk in front of the painting, I was very skeptical. But lo and behold, the bird did change color from blue to black. Now, there isn't any pigment that Jakuchu would have known that changes color. But he devised a way to give that illusion. Now, the brain plays a big part into that. The brain knows that the plumage of some birds is of a black, just like the fur of dogs or of a panther. It's so black that it almost looks blue. And so just like when we look at this, we see a bird and we don't see a series of squares, our eyes and our brain play tricks. And to show you that it's really true, I can show you here 2 images of these detail taken with light coming from a different direction. I'm always in front of the painting, but in one case, the light is coming from the side, that's the top. And in one case, the light is coming directly from behind me. That's the bottom image. You can see that the bird does look different. In one case, overall more black, but the blue is very evident. In the other case, it's more gray, but you lost a little bit the quality, the purity, the depth of the blue. And that's exactly what makes your brain think that at the top, light coming from the side, the bird is blue, and at the bottom, light coming from behind you, the bird is black. If I take away color from those images, just a quick Photoshop, you may get a sense of what is happening. And what is happening is that there is one square. It's sort of like you can see that there are 3 squares. There's a gray square, there's a dark square, and there's another square in the center. And you can see that essentially what changes is that the center, the middle square, in the not the bullseye, but the one right around it, goes light and dark. And that is all it takes. And if we look at the microscope, this is how Jakuchu did it. He painted a whole square black with sumi. He put a dot of blue pigment in the center, and he outlined the intermediate square, what is now essentially a frame, with transparent glue, just like the Nikawa medium. This is like doing a varnish or a glaze in European painting practice. And what it does, it adds gloss. Gloss is like a layer of glass. It's something that will reflect light. Just like you sit in front of you're staring at a window, the light is behind you. You don't see what's behind the window. You don't see through. You just get the glare from the glass. If the sun is at an angle, if the light is at an angle, there's no glare coming into your eyes. You can see through. That shift, adding a reflective layer, so playing with gloss in a type of painting which is traditionally matte, suddenly manipulates light. And by changing the overall level of light coming back from the painting, Jakuchu, or whoever the genius who did this is, made it possible for you to appreciate that blue more or less, hence the color change. This is microscopically what happens. Now, very few people in Edo, Japan had the chance to see these paintings up close, the screens particularly, and walk freely in front of them. Most people, if they enjoyed visual arts, or we should say illustration, they did so in the form of prints. This very famous print shows the bustling print market in Kanda. And that stall is actually the Ejudo shop, the same publisher that eventually will do the Hokusai 36 views of Fuji. We all know the market for prints was really a big industry. The readership, the audience, the customers were plentiful. Technologically, it was the most advanced color reproduction technique in the world at that time. And it would remain so from the time of this print for another 100 years easily. In fact, it even improved with the additions of more colors and brighter effects. Incidentally, there's a genre of prints called urushi prints, where it's commonly said that they used lacquer, urushi, to print it. It was the same trick that Jakuchu used for that screen. The printer used a layer of glue to add gloss to the black areas, making them look like lacquer, but they certainly did not use lacquer. But to go back to the aspect of blue, even with the really high quality in color reproduction that was achievable, up until well into the end of the 18th century, the one thing that was truly missing from the palette was blue. Now, this print has blue, and this print is, well, it could be a landscape in the sense that there is an element of landscape, of open air scenery. But we're probably not, nobody probably is going to argue with me that the blue of the river is not the same blue as we see in this print from about 30 years later by Hokusai. Certainly, if you want to paint landscapes, what you need is blue. And a blue that would work for prints and that would render deep and bright did not exist in Japan for a long time. Open parenthesis here. You saw the type of blue that Kōrin used, the really large crystal azurite. That pigment is extremely expensive. Also, those large crystals are difficult to apply in an even, homogeneous distributed layer by printing. And some would say that it's also too coarse. It would ruin the block. It would make it difficult to clean the block. It would penetrate in the wood fiber. So highly unlikely that those pigments could be used for printing. So what you could use was indigo. Indigo is a very fine powder, very soft. It can be distributed very well on a block. But what you get with indigo is this gray, dull blue. It's not terribly appealing. The blue that Hokusai and Hiroshige and Heizen used from 1820 on is a different one. It's Prussian blue. Prussian blue was brought to Japan first by Dutch traders. Here, this is a small scroll at the Freer Gallery painted by a Nagasaki artist. I'll show it later in entirety. and representing a Dutch couple. Working in Nagasaki, the artists certainly had access to Prussian blue, and the blues that you see there are made with Prussian blue. This is a painting, not a print, of course. And let's go back to my little chart of pigment. You can see the difference between Prussian blue and indigo right here. You can see how Prussian blue, it is much closer to the range of colors that you can get with azurite. It really has an impressive range. For every other regard, is comparable to indigo and just as useful for printing. What Henry Smith in his The Blue Revolution in Edo, Japan, wrote is that indeed, as Prussian blue became available, the world of printing and publishing prints was transformed. And so you see the great series such as Hiroshige's 53 Stations of the Tokaido that use Prussian blue in copiously, and just Prussian blue. It does seem to have superseded indigo completely. It becomes the color of Edo prints of that time, and it really launches the genre of landscape printing. Everybody, of course, knows these prints, and I'm sure that some of you have heard me talking about it before. I was not the first one to point it out, but somebody looking at analyzing an impression of these, a copy of this print, noticed that the key block seemed to contain indigo. Indigo and Prussian blue can be distinguished by their spectral characteristic. Just like we were talking about for infrared study, for instance, Prussian blue is opaque in the infrared. It will still show dark if you take an infrared picture. Prussian blue disappears. And we took a more expensive form of photography using a particular instrument, which my colleague John Delaney at the National Gallery in Washington brought here to the Met. We looked at our print using this camera that will register a full spectrum of the color, the light reflection signature, if you want, at every pixel of the image. And then we can color code the image to show which pigment is used. So we have areas of light blue. So these light blue here, the light blue in the sea, that will register, that have this spectrum and will register blue in this image. Then we have areas of pure Prussian blue at a higher density, so a little bit darker, that will register green. And so the medium blue of the waves, if you want. But then we had a surprise where we noticed that in some areas, you see there's a dip in this curve here. That indicates that indigo had been mixed. Indigo is present as well as Prussian blue. And you see that it's the very dark part of the wave. So we see here the printers working for Eijudo with Hokusai using exactly the same technique that we see Kōrin applying several decades before to darken one blue pigment with a bright hue with a pigment that has a duller and less reflecting character. So you can add two different blues to darken the color without losing the quality of blue, the hue. So that I think is the most striking visualization of what they could do and their sensitivity to the quality of these pigments. But we noticed something else, and I don't think I've ever shown this image. This is actually the results of this work are completely unpublished. This is another very striking print in the 36 views series, the Tempest Below the Summit. And what really was striking for me was the way the cone of Mount Fuji had been shaded to show the storm. So you go with this area where you see the brown of the mountain, And then at the bottom, this very dark brooding area with the lightning bolt. But in between, this area of haze, a transition towards a kind of like a chalky appearance, which is really difficult to interpret. So we applied the same technique where we took a photograph where at every pixel we record the full reflectance spectrum, which for us is the chemical signature of the pigment. And what you see, we have the vermilion, the red that looks brownish, but it's really a red pigment. Here at the very bottom, they add sumi. But what we see is that in the top of the mountain, where we just have that chalky appearance, they were using indigo. So one block was colored with indigo to overlay over the red brown of vermilion to create this appearance of haze as the steam that raises over the stormy area. It reminds me of the optical perspective trick used by European painters, where mountains in the distance would be painted blue to show the scattering of light by dust in the atmosphere. And it's to me an extraordinary trick, because I know that a blue and a darker blue will create an illusion of even darker blue. I know that blue and yellow make green, but I never knew that you can put blue over brown to get that impression of haze. It's truly the first time I've seen it. And I want to finally, as I'm on the home stretch, go back to this time when Prussian blue first appearing in Japan. So there was a reason, as I said, and I want to repeat it, why it would be fundamental for printers. Truly, you cannot get these blues, the blue of the wave in Hokusai's Great Wave, the blue of the rain over the Tokaido for Hiroshige, without Prussian blue. Painters, however, had no need for Prussian blue. When it first arrived in Japan at the very end of the 18th century, and maybe even so during the first decade of the 19th, it was certainly expensive. It was a bit of a curiosity. Why go to something new? The identification of Prussian blue in late 18th century and early 19th century Japan in paintings are very few. In fact, you have one little fish in Ito Jakuchu's Colorful Realm of Living Beings. This was identified by Hayakawa Yasuhiro at Tubunken. You have these little patches on rocks in Iketaiga Red Cliff, which I analyzed at the Freer Gallery. And then this Nagasaki painting, which is clearly, no offense to Nan Reizai, not in the same league, but as a Nagasaki artist, he had access to those pigments. We're all looking at idiosyncratic painters, if you want, in one way or another. But if we look at other artists of the Edo period, of the ukiyo-e school, it's really rare to find uses of Prussian blue in paintings. And but we looked, and we did find. We looked for it, and we did find it, and we found it in Hokusai. So here, the paintings I think have changed their names. They're both of the Freer. One on the left is a fisherman by the shore, and the man with a axe, it used to be called a fagot gatherer. I think now it's called a woodsman or something like that. Those paintings show not just Prussian blue, but Prussian blue and indigo. And in fact, this is a detail of this area on the shoulder of the fisherman. The very dark line is Prussian blue overlaid with indigo, the same way of mixing two blues together, darker blue, that we saw in Kōrin with azurite, and indigo. In Hokusai, done by his printers, Ejudo's printers for Great Wave, and here done by Hokusai with his brush. The technique that we use is this technique called fiber optic reflectance spectroscopy. Here we're looking at another work by Hokusai, which very interestingly to me shows details, and I'm pointing one at one. It's one of these tassels on the obi, and it's very interesting because it's Prussian blue, but it's made to look like indigo. Hokusai is exploring the tonal range of the pigment. So it's almost like making a flute play, like an oboe play like a flute or something like that. It's taking it out of its comfort range, but it's actually working. And to me, it's very interesting that it should be in Hokusai. Now, I should add a footnote. You probably all know that Mr. Freer's preferences were strongly in favor of Hokusai. So Hokusai is certainly overrepresented in the Freer collection, but it's true that by looking at contemporary of Hokusai, and he spanned a long time, we do not find Prussian blue used by anybody else. It's only when we start going to Hiroshige's second that we see Prussian blue, for instance, in some sketches. And so to give you an example, again, maybe it's too broad of a generalization. The painting of a courtesan on the left is by Hiroshige. This one is by Hokusai. You see the range of blues used here. Azurite, there's a beautiful purple, blue-purple details with smalt, but there's no trace of Prussian blue. And here, Hokusai uses azurite and Prussian blue. So it's really experimenting with these new pigment. And I want to go out on a limb, and you're all experts in Japanese art, so you feel free to tell me that I'm wrong. That will only set me right. I cannot but think that Hokusai, by being so interested in the craft of the printer, we know that he really was involved in the printing process, that he knew what the printers were doing, that he would have specific requests on how to render color. He would have learned of Prussian blue by frequenting the printer's shop, and what he would have decided to experiment with it, which is just another one of the hallmarks of a great artist. But these all aspects of the experimental character of Japanese art, where artists are on the lookout for new materials and new technique, is going to come more in focus as we move through the years. And next week, we'll look at what happens when the Japanese ports open up or are opened up to commerce, and how Meiji society reacts to what becomes available, both in imagery and in actually painting material from the West. So I will leave you with this beautiful, colorful print, Yokohama print, from the collection of Lincoln Kirsten here at the Met. And I'll be happy to take any questions. And I thank you very much for your attention and your patience. Thank you.
This is Amy Poster, and I want to thank you very, very much for this phenomenal presentation, taking us so deeply into the subject. And for many of us, we don't have access to this detailed review and time-considered investigation that's been going on for a very long time. And there are many questions from our audience, but before we go to them, I wanted to ask you if Japanese scientists and conservators are applying the same techniques in their studies of pigments in Japanese painting and prints.
So you say if in Japan they're using the same techniques. Yes, so what probably most people know that in Japan, they tend to concentrate on non-invasive techniques. So the sampling that I've shown happening, sometimes not pervasive, definitely doesn't happen in Japan, but techniques such as X-ray, fluorescence spectroscopy, infrared imaging, they are commonly used in Japan. Colleagues at Tokyo National Museum, at Tubunken, and in universities are using them. So there's quite a bit of material coming from Japan on these materials. We also have a wonderful colleague, Yamato Hasuka. She's a curator, but she has done her own work using techniques such as fluorescence spectroscopy to study aniline dyes in Meiji print. So a lot of what I will talk about next week has also been done in Japan.
Many of the members of our audience have expressed a real interest in the various blues that have been used in other arts. And I'd like to ask if you could address some of these, one being lapis lazuli, another being cobalt blue, and which we know from other media.
Yep.
And are they absent from the printing inks and washes, or were they also used?
So, so most mineral pigments are not used in prints, and this is because they tend to have larger grain size and can have angular shape, so they would become embedded in the most blues. They would become embedded in the block. Also, they don't maintain the same deep blue when ground really fine, which would allow you to use them on printing. They're also more expensive. Lapis lazuli is largely absent from Japanese art and Chinese art for that matter. We only find lapis lazuli in Dunhuang in the Mogao grottos, and that's because it was on the road of the caravans from Afghanistan. So very expensive, very rare, came from another faraway place, and they had perfectly usable local substitutes, so they used those. Smalt, which is related to cobalt blue, it's a cobalt containing glass, was used in painting in Japan. Lapis lazuli in the form of ultramarine blue, which is the synthetic form, which was discovered after 1824 in France, was synthesized industrially, and it forms really tiny crystals. It was often sold as laundry bluing. So you would add it to your laundry in the form of a pill, a tablet, because it countered the yellowing of cotton and white wool over time. So that was used as a cheap pigment, and we find it in late Edo and in Meiji paintings.
So following on that, a member of the audience asks about dayflower blue and the blue that we find in much earlier prints and paintings. Do you feel that it was perhaps out of favor during this late Edo and Meiji printmaking?
So I cut off a couple of slides. I cut off a couple of slides that had that showed dayflower blue. There's a lot of talk about dayflower blue being light sensitive. It's not noticeably more light sensitive than others, I'm saying, but it's sensitive to water, and it does give a beautiful blue. I think it was used for a time. I've seen it mixed with I've seen it used by itself. I've seen it mixed with safflower to give beautiful purples. But essentially, when and it was used with great craft by the printers who were avoiding it to bleed in the water medium. But essentially, when Prussian blue arrived, they didn't need to look elsewhere. It was just so beautiful. There's another pigment that's very rare in Japan, and it's called Murasaki. It's not blue, it's a violet purple. And that was used in the Heian period. In fact, we analyzed it. We found an example in a sutra fragment from the Weber collection that was on view at the Asia Society last year. But that seemed to have been used only in Heian times.
Very interesting question from a member of the audience. How are you able to determine whether the pigments on the Kōrin screen, iris screen, date from Kōrin's lifetime? Can you rule out the possibility that some of the blue overpainting of iris was added later?
Overall, what we do is we look at the work very carefully with the conservator and the curator. It would have to be a massive intervention, a massive overpaint. The way the color is so soft, the lean nature of the application would make overall corrections quite visible. Certainly the application of the indigo on top of the azurite is so skillful that it could not be added later. It's an integral part of the rendering of those flowers. It would be like, imagining that the eye on a painting has been, or the shading on the cheek has been changed. Also, chemically, we did not see red flags. Sometimes it's possible to see that, certainly that there are minor elements in the mineral that would flag one way or another, which signify maybe one mine in one prefecture versus another version of the mountain where you see different elements, minor, like zinc, arsenic, etc. And overall, we saw the same chemical signatures throughout the painting, although these, it's not definitive, but it points to a certain unity.
I'm sorry. I said that I wanted to say that many people have asked the question and would like to ask you to clarify the composition of Prussian blue. Can you do that for us?
Yes. Well, Prussian blue, it's a complex structure, but very basically, it's something called ferric ferrocyanate. So it's a compound of iron, carbon, and nitrogen. So when I say cyanate, it's related to cyanide, but it will not poison you, mostly because it's completely insoluble, so your body cannot metabolize it. Iron is present in two oxidation states, which is what actually gives the color. Electrons are bouncing around in an interesting way, which leads to these beautiful blue absorption of red light and reflection of blue light. The way it was done, this alchemist was trying, I believe, to make cochineal, a red pigment, and he was doing so by cooking at very high temperature ox blood, because he knew that it contained the same elements. He was left, I think he used an iron cauldron, and then when he was left with a nasty mess, and when he added another compound which contained iron in a different oxidation state, he got this beautiful blue precipitate, which is one of the stories that they always tell you as a young chemist. It's like, never throw away when you make a mistake, look if it can be useful. So maybe you'll discover something. We tried making it once in the laboratory. The smell is horrible. Don't try it at home.
We have an interesting question from Professor Barbara Rusch, a medievalist at Columbia, who asks, lapis lazuli is mentioned so widely in Buddhist texts, no doubt with inner Asian and Chinese influence. How early can we find it in Japanese sutra decorations and secular paintings?
Oh, I thought about this question when I was preparing the lecture, and I'm happy that you're asking it. There is a mention of when lapis lazuli. There may have been one instance of lapis lazuli in uh, Japan, and it would be either something that's in the Shosoin or an early tomb painting. But as I say, in in all of East Asian pictorial art, the most notable, so Korea, China, Japan, the most notable instance of lapis lazuli is Dunhuang. So in Dunhuang, in wall paintings, and also in one of the, I analyzed one of the textile cloth painted banners that we have here from the part of the stain uh, trove. Uh, we found it, but that is because it would be easily available in Dunhuang because the caravans stopped there on their way from Afghanistan. But otherwise, in Japan, if there is one or two instances, that's what it is. You wouldn't find it much in paintings.
And finally, several people have asked about the economical side of using Prussian blue. Was that part of the question in the use, or was it primarily for its colorful properties?
It's both. So if you want a really beautiful account of this, uh, the article, the Blue Revolution in Edo, Japan, that you can just Google and you'll find it on the site of Columbia University by Henry Smith, is brilliant writing, and he will even tell you the prices of Prussian blue over the decades. At some point, by about 1820 and certainly 1830, Prussian blue had become really cheap. And the story goes that it started being made on an industrial scale in China, where they learned the secret of making it, and they could make it in very large amount, and it was easily imported into Japan, making it cheap. At the very beginning, first decade of the 1800s, you'd probably only find it in surimono prints. Uh, but certainly printing pigments need to be cheap because of the scale of the business. They need to be bright because they were going for a public that loved color, loved novelty, and they needed to be to satisfy those mechanical properties, being like easily distributed, easy to clean the blocks, etc., etc.
I think we have time for one more question, and I'd like to ask that on behalf of Stephanie Wada. What substance did the Murasaki pigment come from?
Oh, it's Murasaki is also called shikon in Japan, and the molecule is now called shikonin. Uh, if you want to know, there's a similar molecule called alkanin that comes from a plant called alkanna used in Europe. They're one, the mirror image of the other, the two molecules, the way the atoms are arranged. It's and it's also purple. The plant is called Lithospermum erythrorhizon. Erythrorhizon from Greek means red root, which is what it looks like. It also has a Chinese name, and it's, of course, and it's popular as a medicinal tea in China. In Japan, purple cromwell. The English name of the plant is purple cromwell. See, I studied. And in Japan, it's a protected plant. It's only found in the wild in protected areas, and you cannot gather it. I think there are some people who have special permissions so that they can dye silk with Murasaki according to the traditional way. Dyeing silk with Murasaki is a very difficult process. Um, Another indication that the level of chemical knowledge of found in antiquity or in historical time, it's amazing because it's not, indigo is and some other dyes are easily to make soluble, penetrate in the fiber. Not so with Murasaki.
Well, we will have time to investigate these questions in more detail next week. when part 2 of this series will take place, and when we will introduce our colleague, the noted historian Henry Smith, who will join Marco Leona to introduce the new red and purple pigments that enliven Japanese prints and paintings at the end of the Edo period. And I believe that JASA has also provided the reference and link to Henry Smith's wonderful chapter in the invitation that you all have received online. I hope that you will join us next week when we can continue these discussions, and anyone who wishes and has a burning question, please be sure to send it in advance so we are sure to get to that next week when we can introduce Henry Smith and bring us together again with Marco Leona. Thank you so much, Marco. And to all of you who joined us today, our many, many colleagues, members, and friends, it's a pleasure to have you with us. Good night.
Thank you.